Our next speaker is going to talk about standards for the streaming of split and network rendered immersive experiences.
Okay, so good afternoon. My name is Imed Bouazizi. I'm with Qualcomm. The title is long, I know, but it's about immersive experiences, split rendering, and standards. So let's get into it. So immersive experiences, what we understand under that is really XR. So XR is like an umbrella term for AR, VR, and mixed reality and so on. And it has, of course, like a very diverse use. Like it ranges from entertainment all the way to like industrial applications and so on. Before I jump into that, so XR is really meant to be mobile. So that's, I think, the key idea that we want to convey here. And what we have today is not exactly that. So on the left side, we see the experiences that we have today. If you just go and buy like an HMD and try it out at home, so you will have either like some toyish type of applications that you can run on the standalone HMD. Of course, what you'll notice, it will heat up really fast and maybe battery will run out quickly. Or you will have like a more robust experiences, but you'll have to have your HMD tethered to PC. Because it's lacking like the power to do all the rendering on the HMD itself. So I can like, from personal experience, I like using things like Microsoft Flight Simulator or even like Google Earth. And these apps only run on PC, so you have to tether it through a cable to your, to your PC. Of course, there are attempts to do that over wireless, but it's not really working fine because mainly wireless lacks the quality of experience that would be required for that. So what we would like to go is to something that is a mix of both worlds. So we would like to move to something that is powered by split rendering, that runs over 5G, and that has a very convenient form factor. Of course, that's a lot of challenge, like lightweight glasses where you don't have to pack like a huge battery that you have to carry. Your neck will suffer from that. So I think that is the glasses that are sleek, that are lightweight, and also durable in terms of the experience. So they should control like the heat dissipation, they should control the power consumption and so on. And that's part of what Qualcomm is trying to do. So with the XR chipsets, so we try to build these basic features of XR in hardware and deploy them in hardware where we can have control over power consumption and so on, and thermal requirements. But of course, that would be limited in terms of rendering capabilities. So the rest will have to be done on an edge server, and that's part of our strategy. So edge is a key part of the strategy, that you have close access to I wouldn't say infinite, but high processing power. And that all is powered by 5G, where we can integrate all of this into the 5G system, optimize the quality of service to control the latency, the bit rate, and so on. So that's the whole idea there. Of course, if we look at the use cases, everyone is talking about the metaverse. And these are quite, of course, sophisticated applications. You will have collaboration scenarios where people work together to develop something or for education use cases. Gaming, of course, is a big part of the metaverse, and also entertainment. So all of these are applications, immersive applications, that would benefit from having a robust split rendering solution. Now the question is, why would this need to be standardized? Of course, we as Qualcomm, we believe in like open standards. We want to avoid like vendor lockdown, that you have to have the glasses and the processing on the edge coming from the same provider. So that's why we need open standards. Also, if you're trying to integrate into the 5G system, I think part of that would require that you open these formats, that these formats are known to both ends, or what goes over the wire is well standardized. Also that it integrates well with the 5G system. If you know what you're carrying, you can ask the network to provide you with appropriate support, like in terms of quality of service, in terms of network assistance in general, also like charging and other features. So now this effort has started in 3GPP. So we're working on something called a split rendering media service enabler. But that's more like a collection of different pieces coming from different standards. Some of them are in 3GPP, some of them are done elsewhere, like OpenXR in Kronos, or video decoding interfaces that is done in MPEG. Like all the integration with the 5G system is done in 3GPP, like how to discover edge, for instance, how to allow the application to convey its connection parameters to the network, so the network can define these quality of service flows, associate them with certain quality of service parameters, and so on. But also the formats themselves, like what would you need for this rendered experience to be like streamed down to the application, and also what would you need to share from your HMD to the rendering server so that it operates and performs the required rendering. So the design is something like this, and we call it MSE, or Media Service Enabler, because we believe this should be something that can be implemented as an SDK, that app developers just link it in, and they should be able to have access to split rendering capabilities, so they don't need to like change their apps significantly. They just need to bind that SDK or library, and then things should be accessible. So it takes care of all the details of like edge discovery or negotiating the session with the split rendering server and so on. So there are two components here: the split rendering server, of course, which runs on the edge. So that could be imagined as something that is, I don't know, Unity or Unreal application with a plugin that grabs whatever is rendered, maybe changes also the rendering loops of the app, and then streams that down, encodes it and streams it down to the split rendering client. The split rendering client, on the other hand, has to talk to the XR runtime to get like information like pause, which is position and orientation, actions on the controllers and things like that, and stream that up to the split rendering server. Now all of this has to happen in a very short time, so what we call motion to render to photon. Latency usually should not be more than 40, 50 milliseconds. There is some correction that can be done on the XR runtime. So say if your pause that you render to is different from the actual pause of the display, so the XR runtime can use like things like a depth map that you provide from the rendering server to like reproject the eye buffers. So that's something that the XR runtime can do. And that's what really brings it up to 30, 40 milliseconds. Without that, I think the limit will be much lower. So let's get into what has been standardized. So this shows how this split rendering functionality is integrated in the 5G system. I think we'll have a call in the afternoon about 5G media streaming, which shows how media streaming can be optimized and supported by the 5G system. So this builds on that. So we still have the split rendering client and server on both sides, but we have something that we call media session handler, and we'll learn maybe more about this in a later talk, which is like the control function on the device. So think of that as maybe a service that runs in the background that allows you to get access to optimized functionality offered by the 5G system. So you could tell it, for instance, I'm starting this session, maybe it's, in this case, it's a WebRTC session. So I have these RTP streams, this data channel, and so on. And this is the requirement that I need in terms of like latency or bit rate. And that MSH will talk to the 5G system in terms of an application function to allocate the quality of service. Of course, all of this can be negotiated in advance with the application provider. So say if you're an application provider, you can provision for your sessions by talking to that application function over what we call there the split rendering interface 1. So that will allow you to negotiate quality of service, for instance, for your applications. That can be, of course, free, or the MNO, that the operator may charge you for that, but that's like maybe a deployment question. Once you have that, as I said, the media session handler can like detect these sessions or receive indication that these sessions are starting, and it can provide the network assistance for it. So without that, let's say, the whole experience cannot be like reliable as we wish for it to be, of course. So yeah, this is a boring slide, but I'll go quickly over it. So this shows the whole setup of the session. So there are main steps. So first, the provisioning that we talked about, and then you would need to set up an XR session and share the configuration of that XR session with the server. So say you have like 2 iBuffers, you're rendering on an HMD. You want to have like an AR experience, so you need an alpha channel. You need a depth channel, maybe to like adjust or allow for rear projection on the XR runtime. So you need to convey all of that to the server. And then once that negotiation is done, you can establish like the split rendering session. You can also inform the MSH to allocate the quality of service needed for that session. And then the render loop can start. Part of that negotiation, I said, you need to provide the XR session parameters, I said, like the projection parameters and so on, to the server. The server in response will give you like a description of each, what the rendering will look like. Now, all of this is very tricky, actually, because when you send your pause to the server to render, you're rendering for a moment in the future. So you have to always like estimate your round trip time for your motion to render to photon. And that render time that round trip time is used to predict pauses. So you can ask the XR runtime to predict where the user will be looking in, say, 20 milliseconds from now. And that prediction, of course, cannot be very accurate, but it's improving. I think some XR runtimes like ours would use like deep learning to improve the prediction and so on. But again, the XR runtime will always be able to do some adjustments. It's not perfect, but the better or the lower that prediction like in the future will be, the better the quality will be. So part of this loop will be to always adjust the delta and so on. I'm running out of time, so I'll quickly move to another piece that we're using here or relying on, which is the video decoding interface. It's a standard done in MPEG. It allows you to control your video decoders on the device. So you will receive, I said, multiple video streams like a left eye, right eye, a depth, and an alpha channel, and you'll need to control these, sync them up to frame accuracy, and MPEG has developed this standard to allow you to do that. Finally, the work doesn't stop there, so what we saw here is what we call pixel streaming. It's like full rendering on the edge, but the spectrum of split rendering is quite wide, and we'll be looking at more advanced forms of split rendering, going up to all the way to streaming 3D scenes, but with baked lights and so on. So that's what we're looking for in the future. And I think that's it. I'm out of time, so
thank you.
let's see if we have questions.
We're going to do something, Ahmad, if you can come over here. We'll take questions. I'll have Rob set up his laptop. So any questions?
Hey, that was great. I love it. But I have a question. So it's great that you're doing all these standards and everything, and you know we all love standards, but sometimes it takes a while for them to become a reality. So what is your kind of guesstimate on when all this stuff is actually going to be out there and operational?
Yeah, that's a good question. Well, we of course, my position, I hope it will happen soon. I think there is momentum, like driven by the metaverse and so on. But it all also depends on how fast we can get to that vision. Like, how fast can we get these glasses to be practical, to be like comfortable to wear, to last long. I think that's in my opinion, I think the determining factor for the success of this. But also like Edge is a big question there. Who's going to pay for that? Maybe a subscription scheme or something like that would be needed. But I think it all plays into yeah, how fast we can get this to market. Thank you.